Good morning, ladies of calculus. Welcome again to room 15.
Learning never ends.
Where learning never ends. Thank you for remembering. Well, she remembers after a long weekend. That's really good. Okay. Basically, what it is, you have something like this, and I don't know about you. I look at this and I say, well, could I expand this to the 8th power? Can I multiply this by itself 8 times and work this out? Could I multiply this by itself 8 times? Could I do that?
What?
Could I go ahead and figure out what all this is to the 8th power?
You can.
How long would it take me to do that?
A long time.
It would take me at least a couple hours to do it.
Hours?
Yeah, well, I don't know about hours, but it would take a long, long time.
What are we on?
But when I do that, how many mistakes am I going to make? If I expand that, I'm going to make mistakes. I'm going to take a lot of time. All right. So what you're looking for is we're looking at U substitution as a shortcut, where we can look at that. And if I looked at something like that, and I saw I had a choice, I know I could multiply that by itself 8 times, and it would take me a long time to do it. And I'm thinking, well, there's got to be an easier way. If there's not an easier way than that, I would just say I probably don't know how to do this one, because somebody's not intending for you to spend hours working out a problem with detailed, right? And so what you do is you have there's something called a U substitution, where you substitute in for something to be able to cancel something out. And so what you're going to do for this U substitution is you take the thing that's the most complicated looking thing here. So between these things here, this trinomial, this binomial, which is the most complicated looking thing here? The first one, right? So this is the one right here. We're going to focus on doing a U substitution on this. And sometimes it takes a little bit of experimentation to do this. So what we're going to do is the U substitution is like this. You say, let U, and by the way, it can be any number, but U is equal to any letter. You can use V or something like that, but just convention is people use U. And so we say let U equal x squared plus 3x plus 5. And when you do that, you have something that makes things a lot simpler for you, because what we can do is we can rewrite this as 9. And now we've said that U is equal to this, and so how can we write this in terms of U, that we define what it is? So if this is U, we're going to have U to the 8th power. Now, already does that look a little easier?
Yeah.
It does, except for this, right? 2x plus 3 and dx. Okay? Does everybody see that first step to doing that? Okay. Now, here's where we start getting a little tricky here. Is what we have is we're going to take this substitution here and take the derivative of each side. And so what we're going to do is take the derivative of each side. We have d. We're going to take the derivative of u, which we're going to call du, and then we take the derivative of the right side. What's the derivative of the right side? 2x dx plus 3 dx. And so now, if we have a common factor, which is dx, we can say du is equal to x is our common, actually 2x. Let me write it here. I'm going to bring that dx out front. So here's the dx, and that's going to be times 2x plus 3. Okay? Does everybody see that? Okay. Now, what we're going to do is solve for dx, because we want to replace this dx here. How do you solve for dx? How do you solve for dx here? Yeah, so we're going to divide out both sides, right, by 2x plus 3. And so this cancels out. And so now we have a substitution for dx. So we can rewrite this as 9 integral of u to the 8th power. And we have this 2x plus 3. And now substituting dx, what's the substitution for dx? du over 2x plus 3. What happens here? Yeah, these will cancel. So we have 9 integral of u to the 8th power du. Now can we integrate this? Yeah, so what is this going to be equal to? How do we integrate this? What's our integration of this? Have we forgotten everything since Wednesday? Okay, how do we take the integral of this? U to the...
U to the, is it the 7? Is it either divided by 7 or is it the 9?
Yeah, one of those. What is it going to be? It's the 9th, right? Divided by 9. So there was some faint memory of that. So what happens? Plus
C.
Plus C. And there's only one thing now that remains to be done, and that's we can go ahead and replace this, can't we? Because since u is that, we can just replace like u with u squared plus 3x plus 5, and that's going to be to the 9th power plus c. And so is that our answer? Yeah, that's our answer. Okay, so to me, this is one of these techniques that you look at a problem and you say, man, how am I going to do that? And then you look at it and to see if there's a U substitution way to do it. Now, honestly, what happens is there are some that are written in such a way that that's hard to spot, but it is, you get practiced at spotting how to do it, and usually it's not too bad. And so so that's it. You have questions on that? So what you do is you should kind of look between the two things. Usually it's the more complicated one that becomes the U, and then that's going to, you hope, cancel this out. And sometimes you might have to do a little more tweaking to cancel something out, but we're going to get some practice at that. Okay? So what I want you to do is, let's look at the next one here. Now, here they give an example problem of this where they have this one right here. If you look at the classwork one, so I want you to do is what are you going to have be your U for this one? Yeah, so x squared minus 1. So I want you to try to work that out. And find du dx. And du dx is going to be 2x, right? And then solve for du and so on. So go ahead and work the rest of this out, and then we'll talk about that in about, what, 3 minutes? 3 minutes? Okay, 3 minutes. So for this one, your du is going to be 2x dx, right?
Yes.
So you do that, you need to manufacture du in the original expression. So you have to multiply by what on the inside and multiply. So you want to change everything to u. I don't know exactly what they're saying. So what it is, you're solving for dx here. So dx is going to be equal to du over 2x. And now we substitute that in. So coming over here to the left, we're going to have x times u to the integral of x and u to the 5th power. And then we're going to go ahead and take du over 2x. All right? And then we can see if we cancel out everything. Can we cancel this out? Yeah, so what we get is 1/2 integral of u to the 5th du. So what is that going to be? Integrate in terms of u. So if we integrate that out, what do we have here?
U to the
1/2 u to the 6th divided by 6. I'll put that 6 out here. Plus c. So that looks like 1/12, right?
Yeah.
And then we can just substitute back in this x squared minus 1 to the 6th plus c. So this is the whole thing worked out here, okay?
Yep.
Is that what you got for it?
Yep.
Okay. Okay. And I find that when I have students a lot of times that'll get really comfortable with this, where they can do these things in their head pretty well. I want to, if you get to that point where you feel like you're able to do it, then great. But be careful about it, because it's easy to make mistakes on these kinds of things. You see what I'm saying? Just that. So my preference is, if I'm working these problems, I want to put the steps there to avoid making mistakes. That's me. I had a guy, Ruben, who I think graduated in 2014, who was really good at this, and he would do this without. So let's look at so what I want to do is, I want you to look at number 6. See if you can do number 6. And again, for this one, it's going to be x squared. You have 1 minus 4x cubed to the 1/2 power dx. See if you can do this one here, number 6. We'll go over it here in a few minutes. Is there anything you see in number 6 that gives you hope that you're going to be able to make this easier? Well, we'll talk about that in a minute, in a few minutes. So how far are you along on this?
Maybe over there.
Okay, I'll wait a couple minutes then.
Yeah.
Just wait a couple minutes. Does anybody have trouble figuring out what let U equal to here? Because I think if you get off to that, and if you, from there, see how you're gonna cancel out that x squared, then you know you're on the right track, and then you know you're not gonna have a problem that, well, shoot, I don't even know if you could possibly work this one out without doing a U substitution. Okay. What we're going to have is let U be equal to 1 minus 4x cubed. So you guys are sounding, some of you, like you're having a lot of fun back there. That's good. I like that. And then we have, if we take the derivative of this, we're going to get negative 12 x squared. And so du is equal to negative 12 x squared dx. So dx is going to be equal to du over negative 12 x squared. All right, so is everybody okay up to this point?
Yeah.
Okay. So now we just rewrite this thing with the u's in here. So we got our x squared right here, and we got our u to the 1/2, and then we have replacing dx with du over negative 12 x squared. And what I like to do is write it like this, where I can just write what I'm trying to cancel right underneath the other one. Does that make sense? So you can just, so I can see better what's happening. So that goes like this. So we get, we're going to get negative 1/12 u to the 1/2 power du. Questions on that? How many got to this point?
I was almost there. I was a step before that.
A step before that? Anybody have trouble seeing to get to this point here? No? Okay. Okay, so let's just go ahead and integrate now. Oops, I forgot, didn't I? Actually, it's negative 1/12. It's that. I forgot to put that there, didn't I? So we have that. So let's integrate now. So we have negative 1/12. And what's our integral of u to the 1/2? U to the 3/2, right?
Yeah.
And it's going to be divided by 3/2, which is multiplied by 2/3. And then plus c. And so now what's our simplification of this? Equals negative 2 over 36.
So,
So 1/18. Is that right? 36, 2, 6. That's right, isn't it? And then we have u to the, so I'm just going to go ahead, since we know what u is already, since we know what our power is, I'm just going to plug back in here. I'm going to put 1 minus 4x cubed to the 3/2 plus c. And that's going to be our answer. And we could write this back in rational and radical form if we wanted to. Right? But we don't need to do that, do we? Okay. So really that's what there is to it. So I want you to go ahead. I want to go to another good one here. I think will be a pretty representative problem. Yeah, go ahead and this one here. Yeah, go ahead and do this number 9. Come over to work out number 9. Do that.
Unless you have like, this is when we get the words.
I'm feeling that you all the time that have freshman dorms, when you have housing apartments on campus.
They have like,
I'm multitask. Anyway, it's just a
it's like I'm not actually, you know? Yeah. Basically. It's like I don't want to get off.
So this is where I would take it. Is this going to be helpful to us here? Did you get this far?
Oh, no, I was confused because you factored it out, but.
Yeah, and why did I factor out? Why did I do that? Why did I want to do that?
Like it's even cancel the other.
Yeah, exactly. So I was looking ahead, so I was thinking, how can I, oh yeah, if I factor out 2. So again, what happens is you just get in the habit of sort of looking ahead a little bit, seeing if there's something you can do to make things a little easier for you. And my brother gave my son a Christmas present, which is this book. It's about mathematics. I have to bring it to show it to you. I'm reading through some of it. But it's this British mathematician who wrote the book, and he wrote the book, he said he became a mathematician when he learned that mathematics, at least the way you learn it, is really finding shortcuts to things. And this is obviously a shortcut. But as you work more towards these things, I find that you can develop intuitions for what shortcuts are if you spot them. So that's what we're trying to do. We're trying to help develop your mathematical intuition going forward. So anyway, we're going to have our bell ring here any second. What I want to do is tomorrow do some more U substitution. We're going to start weaving in some test review stuff too. That's how we're going to do it. So that's how we're going to do it. All right. Thank you, ladies. We'll see you.